All right, this is example 5 from notes 6.3 day 4 about vector applications. In this problem, we're told that there's a traffic light that weighs 1,200 pounds and that it's supported by 2 cables. So on our diagram, I'm going to draw the vector, which is the weight of the traffic light. So I'm going to say this is 1,200 pounds, and that's pulling downwards or in the negative J direction. And we're supposed to find the tension, which is actually a scalar. So we're supposed to just find the magnitude of the vector, which is pulling in along each of these 2 cables. So the sum, there's a hint here that the sum of the vertical components of the forces in each cable must balance out the weight of the traffic light. So we can think that there's a force that's pulling along each of these cables, and together their vertical components have to equal the 1,200 pound weight of the traffic light. Okay, so I'm drawing in the components of each of these forces that are traveling along the cable. So since we know that, since we have a total of 1,200 pounds that's going down, each of these cables, since their angles are both 20 degrees, is going to equally support the traffic light, and the vertical component of each of the cables will be 600 pounds, right? So we can say that the vertical component of vector t sub 1 and vectors t sub 2 are both equal to 600 pounds. They're equal and both equal to 600 pounds. So I know that this part, this vertical component here, is 600 pounds for each of T1 and T2. Given that, I can use right triangle trigonometry now, using this right triangle here, and I can say that the ratio that I want to use, I'm going to call this T2 up here, would have to do with the opposite over the hypotenuse, so I should use sine. So I could say sine of 20 degrees is the opposite side, which is 600, over the tension, which I'm going to call T2. So T2 is the tension in this cable. And then I would solve for T2, so I get T2 equals 600 divided by sine 20 degrees. And if you enter that in your calculator, you'll find that T2 is equal to 1,754 pounds. So the tension in each cable, so the tension in each cable is 1,754 pounds, such that together their vertical components offset the 1,200 pounds.